This is a video of sinusoidal function review 2. The first slide is a warm-up slide, changing radians to degrees and vice versa. So 4 pi over 3, use the calculator here, would be 4 times 180. And then divide that by 3. Is 240. And the other way, 35 pi over 180. And then simplify the fraction. 135 divided by 45 is 3. And 180 divided by 45 is 4. Or you could come over here and do 135 divided by 180 and turn that to fractions as 3/4. And then 5 times 180 over pi so we just go in here, since this is a math input box, and then just hit enter after that. About 286.5 degrees, and then 120 pi over 180, and 120 divided by 60 is 2. We get 2 pi over 3. And then 5 times 180 and divide that by 6. 900 divided by 6 is 150. And 330 pi over 180. Both those are divisible by 30. 11 pi over 6, or if I did 330 divided by 180 on the calculator and then turned it into a fractions, is 11/6 there. And then 3 radians, 3 times 180 over pi is about 171.9 degrees. Then the last one, 225 pi over 180 is, 5 pi over 4. And once again, you can come over here, do 225 divided by 180, and then turn it to a fraction, 5/4. So there's the table. The missing values were 240 degrees, 3 pi over 4, 286.5 degrees, 2 pi over 3, 150, 11 pi over 6, 171.9 degrees, and 5 pi over 4. Next, identify the amplitude period and midline of the following function in degree mode. So if the function's in degree mode here, the amplitude would be 8. Amplitude is always positive, no matter whether it's positive or negative. The period would be 360. Use 360 over 12 is 36. And then the midline would be y equal negative 3. Use the equation editor here. So amplitude 8, period 36, midline y equal negative 3. Problem 2. This is the same idea, but in radian mode. So the amplitude is 5. The period would be 2 pi divided by pi is 2 radians. The midline would be y equal 4. So problem 3, suppose you are loaded into the lowest Ferris wheel car shown at the left. It takes 20 seconds for one revolution. The wheel has a diameter of 24 feet. The bottom seat is at 2 feet above the ground. Sketch a graph indicating the height of your seat above the ground as a function of time t after it begins turning. Be sure to label your axes. So let's make this a... So the lowest the seat is at 2. This is a scale 2 here. Let me use my line segment tool. So y equal 2 is my minimum. And then a diameter of 24 feet. My maximum would be at 26, 22, 24, 26. And then halfway between 26 and 2, add those together, get 28 divided by 2 would be 14. So this line here is, whoops, it's in the wrong place. Let me erase it. 2, 4. 2, 4, 6, 8. That's not a scale 2 here. So 2, 4, 6, 8. No. So it's like 2.5. So yeah, it's 2.5. So 2 would be right here somewhere. And then 26 is 25. So a little bit above 25 would be 26. And then 26 and 2 is 28, 14. This would be 15 right here, so a little bit below 15. is 14. So let's go ahead and label these now. All right, and then this here would be height in feet, and here's time in seconds. So at 0 seconds, it would be at 2 feet, and then it takes 20 seconds to go all the way around. So back at 2. 10, you would be at a maximum, and then 5 on the center line, and 15 you're on the center line. Oh, let me get this right on here. So every 4 tick marks, 1, 2, 3, 4, be on the center line. 1, 2, 3, 4, and then every 20 seconds you would be at a minimum. And so if this maximum is at 10, then the next maximum would be at 30. Then I need to draw a sinusoidal wave through there. In this case, if we started at 0, we'd have a cosine curve. And I would write a cosine equation here. Y equal, my amplitude is 12 cosine, or negative cosine, starting at a minimum, so I guess a negative. My period is 20, and they said use Radian mode, so 2 pi over 20 x and then plus 14. You could simplify this pi over 10 if you like. So y equal negative 20 cosine pi over 10 x plus 14. So here's my graph, here's my equation. And here, plot the points. Here are the points plotted from problem 3. Plot a sinusoidal function radians through the following points. So try to plot one of each type using phase shift. When you finish, hit check my work. So here we started with a negative cosine from the previous page, so we can do that one first. Y equal negative 12 cosine 2 pi over 20, which is pi over 10 x plus 14. And then check it. That one works. So if I want to do positive cosine, I would start right here where my x value is 10. So everything the same. Only I'm starting at an x value of 10, so this will be x minus 10 in parentheses plus 14. Whoops, something wrong there. Oh, there's a negative. Here. Don't want the negative in the positive cosine. And then the negative sine curve. If I start right here, it's a positive sine curve. So y equal 12 sine pi over 10. I'm starting at 5. So x minus 5. Extra parentheses in there. 14. And then the negative sign, negative 12. We have to see where the negative sign starts here. We could start right here for negative sign, x equal 15. Notice all work? No. So the positive sign, 12 sine, pi over 10, x minus 5 plus 14. Negative sign, negative 12 sine, pi over 10, x minus 15 plus 14. The cosine, 12 cosine, pi over 10, x minus 10 plus 14. And the negative sign, y equal negative 12 cosine, pi over 10x plus 14. That was from the previous slide. That was with no phase shift. The other cosine curve would be, if I wanted phase shift, would be x minus 20. If I wanted phase shift in there. Without phase shift, I could just start at 0. Problem 5, suppose you're loading the lowest Ferris wheel cart shown on the left. It takes 30 seconds to make one revolution. The wheel has a diameter of 52 feet. The bottom seat is at 10 feet above the ground. Sketches graph. And then write a sine or cosine curve. So 10. Each of these are 5. So 10 would be right here. There's a line segment tool. So y equal 10. And then add 52 to that would be 62 up here somewhere. And then 62 plus 10 would be 72. So 36. That's right about here. So 25, 30, 35, 36. Something's wrong. 62, 10 or 72, 36. I guess that's in the middle. Yeah. I was thinking that was in the middle, but so 62, 10, and 36. All right, so if I plot the points at time 0, I'm at 10 feet. Let's do it in blue. So 0, 10. And then 30 seconds is right here. 15 seconds. 5, 10, 15 seconds. That would be at a maximum. 7.5. Be on the midline. And then 22.5. The midline. That'll be a midline there. And then if I drew a curve through there, it would be negative cosine curve. For some reason when I'm at home, it's harder to draw with a mouse. So, yikes. Maybe it's my mouse settings here. I don't know. It seems to be more sensitive when I move my hand a little bit. So y equal negative 26 cosine. In degree mode, we 360 over 30. X. And then midline is 36. So simplify inside the parentheses. Negative 26 cosine 12x 36. All right, here are the points plotted from problem 5. It's in degree mode. So the equation on the previous page that I wrote, negative my amplitude is 26 cosine 12x plus 36. So that's negative cosine. Positive cosine would start right here at 15. So everything else would be the same. So phase shift check each one after you did it, so you're not confused. If you got something wrong, then you would know right away which one's wrong. So these two are right. Negative sign. Let's start right here at 22.5. So that one's wrong for some reason. What's wrong with that? Oh, that's a sign. Should be a sign there. And negative. So 2 mistakes there. And then positive sign would start right here, 7.5. I was wondering why that didn't go exactly through. It should be plus 36, not plus 35. All right, no, everything's right. So positive sign 26, sine 12 times x minus 7.5 plus 36. Negative sign, negative 26 sine 12x minus 22.5 plus 36. Cosine 22 cosine 12 x minus 15 plus 36. And then negative cosine is y equal negative 26 cosine 12x plus 36. If I wanted to do phase shift on negative cosine, then I could start right here at 30. I could do x minus 30 here. If I wanted to do a phase shift on the negative cosine. And by the way, this should be labeled time in seconds. I don't know. I can do the x-axis for sure. So this is height in feet again. I don't know. Let's see if I can put it. Yeah, I guess so. And probably should label these points. So this one is 3010. This is 22.5, 36. And this one is 1562. And this point, 7.5, 36. And 010 is where I started. Don't know if I labeled the other graph either. Let me see. No, I didn't, but let me label one cycle here. This is 1026. And this point is 22. 02. 5 and 14. And 15 and 14. That would be one cycle. All right, from 7, the highest tides in the world occur in the Bay of Fundy between the province of New Brunswick and Nova Scotia in Canada one day earlier this year. At one northern point of the bay, low tide of 10 feet occurred at 1:30 a.m. The water level at high tide that same day reaches 60 feet at 8 a.m. So this is 2, 4, 6, 8, 10. So at 1:30, 10 feet. And then at 8, we make 60 feet. So that's 6.5. So 8 and 6.5 would be 14.5. So every 13 hours then is every 13 hours would be one period or a period of the wave cycle. So we'd be right here at 14.5. So 14.5 and 13 would be 27.5. 25. Be about right here. So 8 and 13 would be 21. And so let's go ahead and draw in our max and min here. So the next slide says do Radian Mode. So let's do Radian Mode on this slide also. So halfway between 10 and 60 would be 35. And let's label the points that we have so far. It's 1.5. What do we do in blue? 1.5, 10, and 8. 8,60. Get my fingers on the right keys here. 860. This will be 2160. And uh, all right, and then one cycle halfway between these two. So 9.5 divided by 2 is 4.75. And then 22.5 divided by 2 would be 11.25. So I'm just going to label one cycle here and then try to draw. Oops. It's a little bit too pointy there. So let's do Radian mode here. So y equals negative 25 cosine and 2 pi over 13. X minus 1.5 and plus 35. So on the next slide, I can use that as my negative cosine curve. Good type here. 2 pi over 13 x minus 1.5 and plus 35. And then check. And then positive cosine would start right here at 8. And check that one. So that also works. Negative sign would start right here. $11.25. And then positive sign would start right here. $4.75. All right, all those work. So 25 sine 2 pi over 13x minus 4.75 plus 35 negative sign. Everything is the same except for this negative and the 11.25. Cosine, everything's the same except the starting point is at 8. And negative cosine, everything the same except for the negative, and the starting point is at 1.5.